today you have joined us for our drone demo, and I'd like to present Sergio Bernardes.
Hi, everyone. Uh, I'm Sergio Bernardes. I'm the Associate Director for the Center for Geospatial Research here with the Department of Geography. And today we are going to be talking about a few different options for data collection. And this includes particularly the two drones with two different setups. And just to give you a little bit of background on what this thing is, it's part of a system we put together, part of the Center for Geospatial Research, CGR. And the system then integrates different technologies, drones being one of them. And we do have augmented reality or strategies and how you visualize products created by drones and by other sources as well. Location is very important. So all these are geotagged, and we do have all the images with GPS is involved, and all the images then are geotagged. So let me show you a few things we've done with these different birds. So if you go to a store, this is what you're gonna find. This minus this red part here in the back. This is a standard drone, very common. You can go to Walmart and buy one. What we ended up doing was we modified this drone because the original camera of the drone, although very good camera, 20 megapixel camera, gives you a lot of detail, really great to capture land cover, to create 3D models with the structure for motion, one of the technologies we use. But it doesn't provide spectral information or detailed for the spectral information. But what we wanted to have is a combination of two different sensors where you have a high resolution RGB camera plus a lower resolution. There's always a trade-off in remote sensing. So a lower resolution, in this case here, it's a multi-spectral camera. This camera here, instead of just capturing red, greens, and blues, you can also see near infrared and a part of a section of the electromagnetic spectrum called red edge. Very interesting device because again, it allows you to go beyond visible, near infrared and red edge, and then predict or perhaps quantify, depending on the type of work you do, responses of different objects and different features of the landscape. One of them would be then vegetation. Near infrared and red edge used a lot for spectral analysis and particular for vegetation status, vegetation health. And so very interesting device again. This device is not alone. It's integrated with another part of the device that is then capturing downward radiation. So this is capturing, drone is flying this way. It's capturing what is coming from the ground, vegetation, soil, water. And this part here is capturing what is coming from the sun. So you have incoming radiation and also the reflected radiation from the target. And that allows you to calculate something that is very useful in remote sensing to be able to describe different targets, that is reflectance. It also has its own compass. So interesting device here. Let me show you then how we usually do the acquisition. This drone here, of course, it doesn't have the propellers, just to be, it's a little bit easier to manipulate the drone without the propellers. But let me show you one component that is part of our acquisitions. There's no electronics involved, but this is a calibration panel. So now we are working, it's more than 3 pictures, it's more than just the high resolution 20 megapixel camera, but we want to be able to quantify the response of different targets. And to be able to do that, we do need a calibration panel, an object that has been spectrally characterized. And this is one of them. So before we fly, just before the mission, we go and we collect an image from the calibration panel. We see the calibration panel collect the radiation coming from the calibration panel. We fly, and after the fly, we collect we collect another shot of the calibration panel. And that helps us account for changes in illumination during the flight. Today, as a demo, I'm not going to fly the multispectral sensor. So I'm going to remove the multispectral from the drone, and we are going to be flying just the RGB. And the reason why I'm going to be doing that is because this drone wasn't made to receive this multispectral. It's a little bit too heavy. We ended up 3D printing the adapter here, something that we could demount, something we could use then to present or to add the multispectral sensor. It shifts the center of gravity. It's a little harder for the drone to fly, and it's basically flying a brick. And because the risk is kind of high, we do that for research. Drone needs a little help taking off, but we are not going to be doing that today. So I'm going to be showing you how we fly this without the multispectral. So let's go ahead and remove this. Can they see it? No. Can you? Yeah. So the idea here is for this mount to be just a snap-on thing, to be able to easily add and remove. In this case, some duct tape involved, some Velcro, and that's it. It has its own power source. The multispectral camera has its own power source. So you remove, and it's interconnected, the camera plus the other sensor I mentioned, and the GPS and compass, and you basically remove the whole thing, and now you have your drone standard as if you bought it directly from a store. Okay, so I'm gonna add the propellers. For them. They are color coded. So you need to add the right propeller to the right motor. I feel like it's a cooking show. All right. So we do have propellers we check. The propellers are, there's a whole checklist, and I did some of that this morning in preparation for this flight. By the way, I'm a certified pilot with FAA and authorized to fly here. This is controlled airspace because of NAPS, and we are authorized to fly here. And everything looks good. It has happened. People have reported that sometimes propellers, if you don't check them, they fly away by themselves. So we checked. Hopefully this is not going to happen. So you're getting the real thing. It's when we go to the field, go collect data, we go over all these steps and more to be able really to take off. An interesting thing about this drone in particular, there's no ideal drone. There is just the solution to that particular problem we're trying to solve. This solves a lot of problems, but doesn't solve all problems. But one thing that this drone in particular is very good is it's easy to deploy. It's really quick to deploy, quicker than the other option that I'm going to show you. So here's the drone. The other component of this whole thing is here. That is the controller plus so kind of a game with sticks. Let's see if I can show you this. And interesting thing is there's different sticks with different functions, and drone goes up, drone goes down, left, right. This being a copter, you can fly backwards, you can do all sorts of different things. To control the drone, so you do have the remote controller, but this particular remote controller doesn't have a screen. So for a screen, we use an iPad mini. You can use Android. We've been using iPads. Sometimes they tend to overheat. Screen goes all black during the flight, and that can be kind of scary. So what I'm doing here, this iPad has an app that can then talk to the drone. I'm going to turn the drone on. It's going to go through some check, see if everything is okay. Makes its noises. And let's see if I can show you this. The company that sells this drone is called DJI, and they put an app together. So then the app allows you to control the drone. So I just turned the drone on, and most probably I'm going to be able to see this. It looks all black to me here, like the screen I'm on. But if you could see it, or if you can see it, you're going to see that the app recognized the drone. I do have a drone I know here nearby, and I'm going to allow you then to control the drone. So let's see what we can do with this one.
All right, so we're just gonna reshift here. And just refocus our view.
Kind of has an idea that's a little bit too high.
All right, and again, this is filmed, so we will have this on YouTube. Okay.
That means if something goes wrong.
All right.
So.
Grass is a little high.
Yeah, it is a little high. So in preparation for takeoff, we'll just step back a little bit. And okay, going up.
Oh, it's frozen.
So.
Are we good?
Okay, we're good.
All right.
All right, we're good. So what I'm doing here now, I'm manually flying the drone. Sometimes we do that, but there are apps that allow us to program the drone and fly a mission. And that is usually what we do if we need to fly a large area and if we need to have images collected at an
All right, testing. Are we back?
All right. So there are a few things we do.
Okay.
With the drone manually, especially when you want to fly an area that you're not sure you want to fly it automatically because you may have obstacles, and flying manually you do have more control, and you need to know how to fly it anyway because you need to be able to take over if something goes wrong, and the automatic flight mode doesn't really work as expected. So flying manually is always a good thing. But you do have options, and you can fly planned flights in a way that is you can plan the flight using a PC or computer. You upload the flight to the drone. You press a button, drone takes off, flies the mission, comes back, lands by itself at the location where it took off, and you just go there and collect your image or video. So this is all for this particular model. It's called Phantom 4 Pro. Maybe I should come and collect. Have a photo of us, classic photo of us. And while you're flying, you do have you control the camera, zoom for some models and some cameras, and you also control the pitch of the camera, the tilt of the camera. And this being again a copter, if I want to point the camera some other place, I can just rotate the whole drone. And that's it. Okay. At the same time, I'm here collecting some images. I'm receiving, I see a preview. I see what the camera is seeing, the drone is seeing. My iPad here. If you can see, my iPad is showing what the drone is seeing, plus some telemetry data. So I do have the screen is informing me how much battery I have left, what the distance is, what the height is for the drone. So we do have some help. We're not, even if you fly manually or you fly automatic flights, planned flights, you do get a lot of assistance with this, with the apps that have been put together. How many photos you took, how much space you have left. Very much like a camera. handheld camera. It's just that it's a flying camera. All right. So, and by the way, it doesn't need to be just a camera. There are a variety of sensors that can be. One of the sensors we have integrated. One of the drones is a pollution sensor. It's a particle sensor. So it doesn't create an image. It collects the concentration of particles as you fly. So that gives you numbers. All right, so I'm going to land and I'm going to show you the other drone that you may find has different capabilities you may find interesting. So let's do this. I'm going to land over there because the grass is a little bit too high. So let me.
Oh, I lost the. Oh, there we go. Missed the landing completely.
Okay. So I got
Sorry
it on
about
video
that.
on here, so we had it. All right, sorry guys, we missed the landing there, but we don't want you staring into the sun, so we're just readjusting.
Okay, so I'm gonna move this drone here. Do they have? Are you following the chat or something? Do they have questions coming?
Let's see, we're going to check the chat. If anybody has questions, please ask in the chat, and we'll relay the message to Sergio. So far, our chat is clear.
All right. It's a good sign or bad sign? So now we transition to something a little bit different. I showed you the multi-spectral sensor and the system that goes with it. We like to see, for a lot of the work we do, we like to see detail. It's very important to be able to resolve small features or to be able to describe, not just because you're collecting a photo and you have a well-defined object in terms of representing it as a flat picture, but also because that amount of detail, extra detail, may help you do 3D reconstruction of that object. So one thing we integrated into the system, it's one of these cameras. It's a DSLR camera. The interesting thing about this one is that it's a 42 megapixel camera. So this gives you a lot of resolution to be able to, of course, it creates a problem that if you collect a lot of images, you're going to need then to manage space. And this is one of the challenges working with drones and multiple sensors, is how you then organize your data after you collect all those images. And if you have something like this that is going to create even larger images and larger files, this may become a challenge. But anyway, just wanted to show you, this is, it is seen visible. There is nothing beyond visible here, but it's a 42 megapixel camera and used for detail. Not every drone can fly this, because as you shipped, I mentioned before, you have the multi-spectral that is already kind of heavy. So that other drone, this drone, is not going to be able to fly this camera. So we needed something else. And when you also, now you're bringing a product that is not integrated into a drone at factory. Okay, so you're buying this. This is separate from buying a drone. So there's some work there that involves integrating these different devices. So we have one piece of equipment here that helps us integrate these devices. This is I don't know if you can see. Hopefully you can see this. This is a gimbal used in cinematography. So movies we watch, they are smooth, and there is no the camera work is very smooth because they are using devices like this that deal with the stabilizing the camera, rotating the camera. There's a lot of things happening in the background we really don't see. But this one is used in cinematography, but also can be integrated into a drone. And that's what we have here, at least one of the sensors. This other sensor that we have. It's all black, so no contrast. But this is a camera that sees in the visible, so RGB, and it's a 12 megapixel camera. So 42 megapixels here, 12 megapixels here, 20 megapixels for the other drone. What happens is that when we collect data, very often we want to see beyond visible, and getting data from different sensors and working with data fusion, it became extremely powerful in terms of describing the environment. So what this camera has is one side here is optical, and it works the visible part of the spectrum, 12 megapixel, and this is a 4K thermal camera. So this is allows you to collect both images, RGB and thermal, at the same time. And then for the multispectral, when I showed you the multispectral, we had 5 bands, near infrared and red edge involved. What this guy here does is also infrared, but this the thermal part of infrared. And it collects images in that part, and you can have very, very relevant, I guess, for COVID times, so you can just image a person. When I bought this, in fact, the company, FLIR, the company, they said a lot of people contacting them exactly because of that. Was bought recently. But anyway, it's integrated into the gimbal. Gimbal has its own engines, its own battery, and let's turn it on. Let's see what happens here. What type of control we get. Okay, so I'm going to turn the gimbal on. All right. So you saw that before I turned it on, the camera, although the system had been calibrated and balanced, but still the camera was facing down. But now you have the rotors and servos, they are all working and keeping things in place. And let me just, so I just turned, it has its own remote control, so it's common. When people flying drones using this particular device, you have 2 people operating the system. One is operating the drone, the second one is operating the gimbal. So it has 2 separate remote control. So what I'm gonna do here is just the basic, just to show you it's working. So it rotates. Interesting about this, I mentioned before that if you wanted to look sideways using the other drone, you just turn the drone. Well, this gimbal, you can turn the drone as well. It's also a copter, but this gimbal also turns. So you can just turn the gimbal. And there's a little bit more control here. You can change the roll. And that's it. Okay, so this is working, and that's a good thing. So as you saw this, I'm going to invite you to help me here. integrate this into the larger drone. Let me show you the larger. Okay. I don't know if you see much of a drone because, well, it doesn't look like a drone. It's kind of folded. So I'm going to unfold it. See? Second. All right. So this is a hexacopter. It's called Matrice 600 Pro. And multiple arms, 6 arms. Arms are protected because, as you're going to see, the blades are huge. And if the other blades, the other drone can hurt you, this one can really remove parts of, remove a finger. So this is one of the arms extended. Let's do the second one and lock it in place. And remove the sock. This is remote controls. They like attention. So if you don't give them attention, they beep. One thing I think you're going to find interesting is how this drone can clean this lawn. Because of the size of the blades and because of the many arms, it can really push, can really move air. And we mentioned this as kind of a joke, but this becomes important because if you're flying over, let's say, a crop, collecting images, that you want those images to be high resolution. Usually high resolution means flying low or relatively low if you don't have a super high resolution camera. So the lower you fly, the highest the resolution. But because this is displacing a lot of air, if you fly too low, the leaves, they're going to move a lot and they are going to create blurry or low quality photos. So that's one thing we need to take into consideration when we plan the flight. We are thinking about resolution, and in fact, we are thinking about all the potential, all the possible resolutions. We are thinking about spatial resolution. We are thinking about spectral resolution with those sensors. Temporal resolution, because we can fly more than once, or have a little bit more control over when we fly in comparison to airborne, or in comparison to orbital, to satellites. Big advantage is even during cloud days or cloudy days, you can fly this satellite. Depending on what the satellite is flying, it's not going to be able to see through clouds. But this guy here is flying below the cloud level. And then even if it's kind of cloudy, you can fly. If you're going to get good data, then it's some, you may not. Big difference. This is a huge drone, right? So scale. It can carry 13 pounds. Right, that's great. Thanks. So you see the difference. And it helps a lot if you have heavy payload, and if you want to carry multiple sensors. This is exactly what we've been doing. Then you need a drone that is able to carry all that extra weight. And when you think weight, is not just the sensors themselves, but you need to power them. So you're carrying batteries, and batteries tend to be kind of heavy. So it's so So you do need a large drone. That white drone, the Phantom, takes one battery. This is one of those, the batteries, it just kind of a drawer there. You just add the battery to the drone. This, you may fly for 20 minutes. If you're not flying the extra sensor, multi-spectral sensor, you may fly for 20 minutes, perhaps a little bit more than that. Safely 20. One battery. Well, now you're flying a hexacopter, not a quadcopter, that can lift 13 pounds. It has its own power demands, including it takes 6 batteries. And it takes 6 batteries not just because, in fact, it uses more power, but because some redundancy was added to this drone. So even if one of these batteries failed in flight, the drone can still land. For the other drone, the white drone, if a battery fails, then the drone falls from the sky. So this is a good thing. So a lot of technology being put into these drones, a lot of intelligence. These drones have been programmed. I mentioned to you collision avoidance is one of the things, but a lot of time being spent programming these drones so they're really smart drones. And that helps a lot, to the point that I always say it's much easier to fly this drone and the white drone than a cheaper drone. People usually think, I'm not going to invest in a more expensive drone because I want to learn how to fly first. So I'm going to spend less money and buy one with less capabilities, and then you may become a great pilot. And when you go fly these drones here, you're going to see that some of that skill may not be required because the drone is doing a lot for you. The whole stabilization thing, I'm flying using the remote control. And if I just, I don't touch the sticks anymore, just let the drone fly by itself, it's just going to hover. It doesn't go anywhere. So really, okay, so I'm here installing the batteries. And we have one left. So when I mention deployment time, this is one of the things. If you're gonna go to the field, collect some data, and take this drone with you, you need to account for some extra time to be able to prepare the drone, make sure everything is in place. It's not as fast, the deployment is not as fast as the other one. So, right tool for the right job. So I'm just checking here, see everything. Usual check, blade check, no cracks. Always good. Some of our checklists really resemble main pilot checklists. And when we apply for the certification with FAA, there's a knowledge test that involves knowing airspace that is commercial airspace, controlled airspace, knowing airports, and all the coding for runways. Probability that this drone would take off from Atlanta Hartsfield from a runway there is kind of small, but you need to learn those things. All right, so we do have the drone, seems to be fine there. What we need to do now is get the gimbal and install the gimbal. So the gimbal, I'm gonna detach it from the arm and remove it here. one thing that makes things really easier for us is that the gimbal and the drone came from the same company. So in theory, they talk to each other. So that really helps with the integration. All right, let me just do this, make my life easier here. Usually it doesn't require all that. So you're seeing the behind the scenes, how you integrate this thing. One is there. There's a direction this should go, and it should snap in place. Just did it, and then I turn a knob. Part of the concern is, as the drone is flying, you think everything is very smooth. There's a lot of vibration there, so you need to consider that whatever is vibrating, they get loose and again fall from the sky. So they need to be tight.
So Sergio, before we fly, we actually have a question in the chat.
Right.
I think it might have been asked a little while ago, but where is the coolest place you've flown?
Oh, let's see. Well, maybe one of the places I remember with that was particularly interesting, I guess, was somewhat close to Hartsfield International. And because of all the airplanes there, you need to be extremely careful. And when I go fly, like what I did here, it's controlled airspace. You go fly, controlled airspace, you need to get special authorization. And if you're gonna fly controlled airspace that is busy like a Hartsfield International, you really need to get that authorization. And so I got it. I found it was interesting. It was, but I was still thinking about the risks. There's always a risk. They're saying you go to YouTube, you're going to see a bunch of these crashing and doing all sorts of it's technology, and the technology fails. So things may go wrong. So thinking of that, I bought insurance, $1 million insurance. And of course, $1 million is what percentage of an airplane and lives that could. So we really try to be careful, follow the rules, all the rules and everything. But one of the flights that I think was particularly interesting to me. There was another one in 2017 at Sapelo Island. Amanda was there. That was just after Hurricane Sandy? No. Irma. And then we went there, and there was a stretch of beach that was removed there, and basically created a new island, and we were able to fly over it, and we got some attention, people contacting us because UGA discovered a new island, and in fact, it's just a process that happens, commonly happens. Those are barrier islands, so it's just part of the dynamics there. But that wasn't a very cool place, very interesting place because of the hurricanes. Also, when you fly, usually you're not supposed to start flying and just let the drone do its thing, and you sit there, you're not paying attention. One of the flights, Coast Guard, flying really, really low, a helicopter, lowest than the maximum, the ceiling for the drone. So we were right. We are not flying above the limit. Coast Guard was flying really low. So that was interesting. And also we were advised, pay attention to the drone, look up, but because of the hurricane, a lot of snakes have been displaced or habitat being affected. So we were looking up, and the snakes were, and we saw a bunch of them as well. So anyway. All right, so this is there. There's one piece that I need to attach here. Got excited. It's harder when you don't see. When you see, it's a little bit easier. They made our lives so much easier now with these drones. They used to receive a kit by mail with just parts, and you would need to. It can be a lot of fun, but if you're just interested in collecting data, then you're going to spend a lot of time just assembling, connecting A to B, B to C, and all that. So it was for a while. This particular model was being sold, and you're going to see the YouTube videos. This is again the Matrice 600 Pro. The Matrice 600, the one that precedes this model. If you bought it, you had a lot of assembling and things that you had to do yourself. But this is not the case. All right. Okay, so we may be, because this drone, because of the size of the blades and the risks and all that, so we're not gonna, of course, take off here. We're gonna go.
Okay. All right. I'll grab this.
I don't think we need to move.
Okay.
Turn on. All right. So I'm here swapping equipment. That drone, the Matrice 600, has its own remote control. So remote control, same company, but the system has different capabilities and it has its own remote control. So we're just swapping remote. So another thing you need to do, when you start integrating things, there's a lot of things you need to turn on before you take off. And you forget one of them, the drone may fly, but you're not gonna collect it. So for this guy, I need to turn the drone on, I need to turn the gimbal on, and I need to turn the camera on. And they're all different switches. And of course the remote.
All right. If anyone has questions, please ask. We're just getting as Sergio explained, he has to do a setup process here, and he's going through those stages that he just explained. We have someone that said, wow, that second drone is huge.
And it is.
I'm gonna turn it on, but the propellers are not gonna go. And it's kind of loud.
Oh yeah, that's right, it is loud.
All right. And it's a good thing it's loud, because if something this size is gonna move and potentially, I mentioned redundancy. If you can see from here, there are 3 antennas, and the top there, the white ones, and a compass. So GPS plus compass. Again, part of redundancy. If one fails, the system still can find its way. All right. The bomb is ticking. And I'm just launching here the right app, because it's one app for the drone. You go through some questions and information. This drone, depending on how much you carry, it can fly for 30 minutes, even more. So the other one, about 20. So that's another point. You can even fly, a small camera and use the large drone to fly a small camera just because you want to fly a larger area. The drone is going to give you a lot of flight time. But of course, it takes 6 batteries to fly 30 minutes, so perhaps a little bit more than that. So what we have 3 sets of 6 batteries, and we do the replacement as we go. All right, so we're gonna move away, and everything looks good. I'm gonna turn it on. Okay, the propeller's on. Propeller's on. Already cleaning the lawn. Gonna go up, taking off. Landing gear goes up. You see that? Up. Good. Landing gear. So I'm gonna move the landing gear. So right now it's collecting thermal images. And also RGB. It has its own compass and GPS, so the images also will be geotagged. Birds tend to get curious about drones. Sometimes they get close. And I've seen stories about birds getting too close to this guy here. So again, when integrated with the app, everything communicates. So I'm gonna land. Noisy.
Looks like we have another question as well. So, how long do the large drone's batteries last? And how is the data stored on the drone internally, on the iPad, or in the cloud?
Right. So you do have, depending on what type of sensor you're flying, your payload. If you're flying that heavy 42 megapixel camera, you may choose, that's one thing we want to do, fly multiple sensors at the same time. So each sensor has its own capabilities. And if you keep adding sensors and more weight, your flight time is going to go down. So if you're flying just a light camera, you may get 30-something minutes. And this is usually the way you fly. When we reach 30%, we are getting telemetry. And when we reach 30% of battery, there's 30% of battery left, then it's time to bring the drone back home. It depends also on conditions. If it is too cold, it may happen that the battery, the amount of battery you have, is not being reported correctly. So that depends on a few different things. But 30% is what we do. It has happened if it's just one more sector there that we need to fly, then perhaps 20%. But that would take you, for this drone, so about 30 something minutes. The other drone, about 20. And the data, you have a few options. And it also depends on the sensor. For this drone, each camera, each sensor is collecting and storing its own data. So it has micro SDs, and micro SDs then are storing. In this case, by the way, it's a double micro SD, so you have redundancy there. If one fails, you have a backup, and it's all embedded as part of the sensor. And some of the flight applications we use, it may happen that if you're next to good wireless network, you have the option, after you fly the mission, you have the option to upload your photos to the cloud, and not just for storage, but you can start processing in the cloud. So there are services online that allow you to create your products, create the models, create mosaics of those photos, because what you end up with is sometimes thousands and thousands of images, and it's all great, but you want them all stitched together to be able to see as a mosaic, and these services can do that for you. So in that case, then you upload to the cloud. The drone is sending you a resampled version of the original image. So you do have the higher resolution image being stored. It's part of the sensor that is there. The sensor has its own storage. The original image stays there, but the drone is sending you a preview of that image. It's not a thumbnail, or at least it's higher resolution than that, but it allows you to see those images. And so you have an idea if you covered all the ground or everything you wanted to photograph or to image, and if there's any missing parts. But yeah, that's how we do it. So I'm going to switch it off. And look at that. Time, yeah?
Timing.
Anyway, I know you have other activities, but that's all I have to present. If you have any questions, you can always find us here again, Center for Geospatial Research. Find us online as well, and Department of Geography. And if you have any questions, you can shoot me an email. If you're interested in this type of technology, I have students working with me on this. So we are not only using the technologies, but we are developing and augmenting these technologies. So there is also that front, that is research and some engineering involved as well, and geography. It's a mix of things. So any questions, any comments?
Well, I wanted to mention we are going to be hearing from someone working with Sergio. Where am I? There I am. We're going to be hearing from one of the students that works with Sergio tomorrow during our student presentations.
That's correct. That's Andrew Gass, and he's going to be talking tomorrow. And I'm going to be part of the panel this afternoon from 5 to 6.
That's right, and that's actually next up on our itinerary for today. So, Sergio, thank you so much for giving us a tour of the drones.
My pleasure.
Thank you.
We look forward to hearing more of the behind the scenes part of it this evening. So we're looking forward to that. So thank you again, and we'll sign off here. But again, if you have any questions for Sergio or anyone else in the lab or how to get involved, you can find him at the Center for Geospatial Research in the Geography Building, and you can email him or you can email him.
And we've recorded this entire session, including some of the takeoffs and landings and some higher resolution cameras. So we'll be posting that in the next few days to YouTube. So